Hi, my name is Matthew Hansen, and this is the professor course matching problem solved through the Gale-Shapley algorithm, um, or otherwise known as the stable marriage problem, although this was done with a little bit of a variation. Um, so, just kind of going over the code review portion of this in particular. The main logic of the matching algorithm occurs here in this while loop, where while any course is unassigned, we need to go ahead and grab those unassigned courses and then order by descending. The reason we're doing this is because courses that are higher level require, well, they should be assigned first so that they get preference over courses that are lower level. That way we can get the most qualified professor to teach those courses first. Where just because they're the ones who are better at teaching those courses. So for each of those courses, we're going to go ahead and see why. And this, if else, the premise of it is as long as there's a professor who doesn't have a full course load, then we're going to go through those professors. Well, we're going to have the course proposed to the professor in particular that's next on their list. And I'll go into that because that's where a lot of the actual a lot of the logic takes place. But if all of the professors already have a full course load, then we're going to assign that course that's left to an adjunct. So let me go ahead into the add professor logic. Oops. So adding the professor, it starts off with each course generating a list of weights for each professor according to the professor's preferences and the course's level and stuff. So that in particular looks like this. So for every professor, because every course is aware of every professor, we're going to go ahead and we're going to do a weight calculation. So I'm going to kind of skip this part first. I'm going to go to this part. The premise is we have preset dictionaries for what the weighting that we're going to give to each section is. So for example, if the professor, if the course in particular is their first choice, let me scroll up to here, they're going to get 6 points of weighting. If it's second choice, 4. If it's other 2, and if they didn't list it as a preference, we're going to give it a 0 weighting. The higher weighting, the better. And we do the same thing with the professor's position, so they're professor 4 on down. And then course level 2, we start at 10 points if it's a 6,000 level course, all the way down to 2 points for a 1,000 level course. So that's simple addition. We also have a multiplier on the professor's years of experience. So the longer that they've been there, the more weighting points that they get. 0.1 is actually kind of a low preference weighting, but for our purposes it worked. And the last thing is the preferred time bonus. So if the class happens to be in the professor's preferred time, we go ahead and we give them 6 points of weighting. If it isn't, then they prefer not to teach it, so we're going to give it a 0 weighting. And so that's how we generate the weighting of each professor to course. So once we have that, all of a sudden we have a list of professors that's the preferences for the course. So the course can then just take the highest weighted professor and can propose to that professor. And it's up to the professor whether to accept the course or not. If they accept the course, then the course is no longer unassigned, and we are going to assign that professor. If the professor has a full course load, and we'll go into that in a little bit, but let's just say that they reject, they don't want to take the course, then we're going to remove the professor from their waiting list. So that way, the next round, when the course proposes to a professor again, it'll propose to the next highest weighted professor, and that'll continue happening until it's assigned. So the professor, what are their qualifications for accept? Well, not their qualifications. Why would they accept or reject a course? So if they have a full course load, well, no, let me go. So if they don't have a full course load, and there aren't any time conflicts, then they're going to accept the course because they have room. But if they don't have full course load, Oh yeah, so if they don't have course load, so they go through that. Um, yeah, so in this section, if they don't have a full course load, but, and this is kind of the key thing, even if they do have a full course load, there could be courses that they want to swap in. So say, for example, the course it's proposing is higher weighted than one of the classes that's on their list. So what we go ahead and we do is we remove the lowest weighted course that's lower than that new course in. But we also have to make sure that that course is now unassigned. So this is kind of you have to forgive me, it's a little bit trickier to explain, but that the main premise is professor has however many courses, which is normally 3 because all of the courses are 3 credits, but they have to be able to know which one that they want to swap for. And a key part of that is, are there any time conflicts? Because even if they like that course better, if it interferes with another course, then they really can't take it because the other course is already higher weighted for them and they liked it in the first place. So no need to swap, as it were. So yeah. So that's how that works. The professor accepting it is a lot trickier just because it has to deal with time conflicts and multiple courses. But once that's all said and done, and all of the courses are assigned, whether to a professor or to an adjunct, then we're going to get some results. And before I run the results, we do 3 key checks. One, first of all the classes have to be assigned. If they aren't all assigned, then the program's failed. So we do a quick check to see if any course is unassigned. Also, we need to make sure that all of the professors are teaching the number of credits that they have assigned for the semester. Some professors have more, some have 9 credits, some have 12 or more. So we do a check to see if if any professor isn't teaching the correct amount of credits that they signed up for. So we're hoping to have none for either of these. We want all classes are assigned, and we want all of the teachers teaching the amounts that they want to be teaching. Finally, we want to make sure there are no time conflicts, because even though we've assigned these classes, if the classes are assigned at the same time for one professor, that won't work. So we do a quick check to see if there's any instance where there's a time conflict. Just going through the professors, the courses that they're teaching, and getting the class times and making sure that for each professor those class times are distinct. So they're all different, which we're tracking through just enums. So like M2 would be Monday second period or whatever. And then the rest of this is mostly just formatting. So let me go ahead and run this program. So you'll see up at the top, all the classes are assigned, all the teachers are teaching the correct amount, there are no time conflicts. All the output of each of the matches looks like this, with the professor making sure that, showing how much credits they're teaching out of credits that they signed up for. The course weighting, which I'll get into in a little bit. Well, I guess this is the average weight of, so this is the average of the classes that they're teaching. So for example, Professor Tang is teaching 2 courses of 2300 and 2810. And the highest weighted class he has is 2810, so it's a 21. But if you take the average of each of these weightings for each of the particular classes, you'll get about a 17. And it's formatted like this for all of the professors. Kind of one of the key things to know to make sure that we actually got, to see whether this was successful or not, is you want the weightings to be higher. For example, the average professor weighting, once we've summed up all of the weightings for all the professors, is a 14, with the highest professor being weighted at an 18 and the lowest at a 7. So this is as we saw earlier, there was weightings of 21 and stuff for specific classes. So it would be nice to have the average be higher, I think, in an ideal case. But from what we do have, the average is closer to the highest average weighting than it is closer to the highest average weighting for a professor than it is to the lower one. So I think we've actually done quite a good job since we're only 4 points off of that. The other thing to keep in mind is here. So separate from all the classes assigned to the professors, we needed to make sure, we need to keep track of how many classes actually need to be taught by adjuncts. So we have a total of 12 credits with these 4 classes that are listed: 1400, 2600, 2 2600s and one 2810. For whatever reason, whether it's scheduling, most likely because it's so late in the day, it just wasn't going to work. But figuring out how many adjuncts to actually hire is kind of an interesting question, and I think is very specific to each university. One adjunct could handle 12 credits, but maybe a university has a program where they want to have an adjunct try out just one class at a time or something. So maybe it would be 4 adjuncts. So since I'm unable to make that call, I just listed out what classes needed to be taught and how many credits it is total. One of the... Yeah, so this is the program. This is how it works. Obviously, to make it into more of a commercial kind of software, it would take a lot more work for actually getting the raw data in, handling the input, handling just changes in courses. Maybe the professors don't like the courses that they're assigned. Maybe they want to swap. Changing that on the fly would need to be able to be handled and stuff. Or maybe, just weird stuff comes up. So, but yeah, this is the program. Thank you.